All right, so here's a review on optimization. When we say something's optimal, those are stories involving finding either a maximum or minimum. And that means we need an equation, we need to take the derivative equal to 0 and solve it, and we need to make sure that equation has one variable. So sometimes you have two, so you can do a substitution to make it one variable. So let's look at a couple examples, and then you get a chance to redo that quiz. All right, so the product of two positive numbers is 100. Find the two numbers so that the sum is as small as possible. All right, so this, as small as possible, means it's a question to do with minimum. So we have two numbers. So x can be the first number, y can be the second number, and says the product of two positive numbers is 100. And it says find the sum, so it's as small as possible. So I'm going to say S for sum, and this is my primary equation, what I'm looking for. This one is my secondary equation. So I have two variables right there. So I'm going to solve for one of them. I'm going to divide by x. And then I'm going to do a substitution so I only have one variable. So instead of y, it's going to be 100 over x. And instead of 100 over x, I'm going to write that calculus friendly so I can do the next step. So the first step is the equation. The next step is the derivative. And then the last step is to make it equal to 0 and solve it. So often making it calculus friendly can be helpful. I mean, algebra friendly could be helpful in terms of solving an equation. So instead of x to the negative 2, write it as a fraction. I'm going to add 100 over x squared. And then I'm going to cross multiply. So x squared equals 100. Square root it. It's not positive and negative 10, so the numbers are only positive, so the answer is 10. So I'm going to draw a number line and put 10 there. These are positive numbers, so it's 0 on. And then I'm going to make sure, using the derivative, that it creates a minimum. So if I plug in a number like 1 into here, it gives me a negative answer. If I plug in a number like 20, so 100 over 20 squared, that's a fraction that's smaller than 1. So now the answer is positive. That's a minimum. So I found the first number to be 10. To find the second number, we know this, 100 divided by whatever the x value is. So that means both numbers are 10, so that the sum is as small as possible. All right, second example. So here's a field with fencing around it. You're told that you have 240 feet of fencing. And what we want to do is to maximize the area. So my goal is to maximize the area with this fencing. And I need to create an equation. Take the derivative equal to 0. So the equation we begin with. So fencing is how many x's do we have? How many y's do we have? Be careful because the middle is also y. So y. That's 240. That's going to be secondary because I already know the answer. I'm looking for area. So what's the area here? And these are the same size. So if you maximize one and double it, then it'll be fine. So x times y. And if you look, it's actually 2x times y. Let's do it that way. So 2x times y is the area of this rectangle, and that's what we're trying to maximize. I don't know what it is. So I have too many variables, so I need to solve for one. So I'm going to solve for y. So I'm going to subtract 4x and divide everything by 3. So 240 divided by 3, that's 80. This is 4/3 x. All right. So I'm going to come back here, take out the y, and put in 80 minus 4/3 x. Now I have 1, and I'm on my way. I want to take the derivative equal to 0 and so on. So I'm going to distribute first to make the derivative easier. 2 times 4 is 8, and that's x squared. And now I'm going to take the derivative of this. So 160 is the derivative. 2 times 8. And then subtract 1 to the exponent. And then solve this. So I'm going to add 16 over 3, and then I'm going to multiply times the reciprocal to both sides. If I multiply by the reciprocal, that means x is by itself. 16 goes into 160 10 times. So 3 times 10. And then I need to make sure that number is a maximum. So I'm going to draw a number line into the derivative, which is right here. If you plug in positive 1, this answer is positive. If I plug in 40, this becomes a fraction that becomes bigger than 160. So it goes from positive to negative, which creates a maximum at 30. So when x equals 30 feet, and then I have to solve for y, but we wrote down here what y equals. So we're going to plug in 30 for x and then solve it. So 3 goes into 30 10 times, and then 4 times 10. So altogether that's 40. So what dimensions? What dimensions would maximize the area of that rectangle? And the answer is 40 feet by 30 feet. All right, there's your review. Mr. G Math over and out. Good luck.